Hi everyone! In today's tutorial, we're going to learn how to download Scratch 3.0 onto our computer. So go ahead and open up your browser and just type in Scratch 3.0 download. And it's going to be the very first link that pops up, so go ahead and click that. Let the website load. I'm using a Mac, so I'll be downloading the one for Mac OS. If you're using Windows, then just download the one for Windows. You can get it from Microsoft or direct download from the browser. I'm going to download from the Apple Store like it says, so I'll go ahead and go to the Apple Store and just type in Scratch. It's going to be the very first one that pops up, so just click Open. Now you can either access it offline like this by downloading the app, or you can access it online by clicking on Create. So this is how it looks like when it loads. So it looks exactly the same as the offline version. The only difference is that you will need Wi-Fi or data connection in order to access it. And when you save a project file, when you click on File and Save to your computer, it gets directly downloaded to the download folder that you have. So it doesn't give me the option to save it to a specific place. But with the offline version, if I click File and Save to your computer, it will ask me where specifically I want to save my project file. So that makes it a little bit more convenient for me. If you want to load your project file, go to File, Load from your computer, and choose whatever project file you want to work on. So that is it for this tutorial. We learned how to download Scratch 3.0 onto our laptop and also access it online. Hi everyone! In today's tutorial, we're going to explore the workspace of our program Scratch 3.0. So on the top here, we have our menu bars, File and Edit. Over here, we have our file project name displayed. We have 3 tabs on the left here, our code blocks, costumes panel, and sounds panel. In the middle here, we have our big script area. And on the right, we have our stage. Above our stage, we have our green flag and our stop button, which will play and pause our stage animation. Over here, we have the sprite panel, and on the right here, we have our stage panel. Let's first look into our sprite panel. Currently, we only have one sprite, which is the kitty. If we want to delete our kitty, all we have to do is click on that trash can button. We can add more than one sprite by clicking on this Choose a Sprite button. Then we will open up a library of different sprites to choose from. We have animals, people, fantasy, dance, music, sports, food, fashion, and letters. I will choose an apple, and maybe I'll bring in a bear as well. So we have 3 sprites with us. We can also change our backdrop by choosing Choose a Backdrop. I will choose an Arctic. Now that we have a few sprites, we are ready to code. So if we go ahead and look into our code blocks, we have a variety of code blocks to choose from, and they are color coordinated and organized into different sections. If I want to choose a specific code block that I want to use for my script, all I have to do is drag and release it onto my script area. If it's a little bit too small, I can use this plus icon to zoom in, and if it's too big, I can zoom out like that. So once you have your starting block ready, you can mix and match different code blocks to write your script. If you have a block of code that you do not want anymore, then just detach it from the rest of the blocks and release it to the left, then it gets deleted. If you want more than one code blocks to be deleted, just drag the topmost block and release it to the left. To check and see if you are writing your script on the right sprite, all you have to do is check which icon is being displayed on the top right of your script area. Or you can check and see from the sprite panel which sprite gets highlighted. So currently I am scripting on my bear, as you can see on the script area as well. Let's say I have a few blocks of code that I really like and I want to duplicate it by copy and pasting it onto another sprite. I can do that by dragging and releasing it to another sprite, so when it vibrates, then I can release it. When I go to that sprite, then I can see that the code block that I duplicated is now on that sprite. Now let's move on to our costumes panel. In our costumes panel, sometimes a few of the sprites come with another costume. So this one, our bear is standing up for costume B. Let's go ahead and look at Kitty. Kitty comes with another costume as well. And if we switch between the two, it looks like Kitty is running. Some sprites, however, don't come with another costume like the apple here. But a cool thing that we can do is change the color of the apple using the paint bucket tool. We can also use the erase function to erase part of the sprite, and we can also use the brush tool to paint on it. All the sprites also come with default sounds, so the apple comes with this sound. Let's hear the kitty. And now if we want to add another sound, we can just click choose a sound and it opens up a library of sounds that we can choose from. So you can choose whatever sound you want and add it to our sounds panel. You can also upload a sound of your own from your own computer. Once you are ready with your code and you want to run it, all you have to do is click on the green flag. So click the green flag and see how our code ran. The apple moves 10 steps and says hello for 2 seconds. Now let's talk about the 3 buttons that we have over here. These are the different view formats that we have for our stage. Currently we're on this one, and if we click on the one on the left, the script area gets bigger and our stage gets smaller. If we click on this one, then it shows our stage on full screen. This is really helpful when we are done with our code and we want to see our stage on full screen. To minimize, all you have to do is click on that button again. To save and load our code, we can go to File, Save to your computer, and save it to a designated folder that you want and name it to whatever name you wanted to save it as. To load and open up a project that you already have, just click File, Load from your computer, and choose a file project that you want to open up. So that brings us to the end of our tutorial for this video. You can play around and explore more features the Scratch program has to familiarize yourself with the workspace and advanced features they have. Now for our challenge task. I want you to script a scene where a bear is in the middle of the Arctic and screams, "Ah!" as it thinks to himself, "Huh? Where am I?" So first, to do this, you will need to edit the brown bear into a white bear. Now don't get confused with the polar bear sprite. That is not the one we want to use. We want to use a brown bear and edit it to become a white polar bear. Second, we need to edit the sound so that the bear screams when we play its sound. To make a sprite play its sound, use the start sound block from the sound panel. Lastly, we want to get him to think, "Huh? Where am I?" Now don't get confused with the say blocks. Remember, think blocks show thought bubbles on stage, whereas say blocks show speech bubbles when the code is running and shown on stage. So have a go and see if you get the answers right. The answer keys are going to be provided, so check out the answer keys once you're done with the challenge task. We will first have to change the backdrop to an Arctic. We'll get rid of our kitty and bring in a brown bear. Let's bring in this guy. And remember, we have to change the color of the bear to be white so that it becomes a polar bear. I will change the fill color to white by bringing down the saturation and then use my paint bucket tool to color in my bear. So to color in the details, click on this plus icon and we'll be able to color in the very specific parts. Looking good. Okay, now we are ready to code. First, we want our bear to move 70 steps to the right. Then we want it to make a screaming sound, so I will go to my sound panel and choose a sound. I'm gonna bring in Scream 2. Yep, that's the right sound. Okay, now I'm gonna bring in my start sound block. And after it screams, I want it to think, huh, where am I? So that's under the look blocks, which is right over here. And it's gonna say, huh, where am I? And to finish off our code, we want it to play when the green flag is hit. So let's go ahead and put it on full screen, and when we hit the green flag, the polar bear is going to move 70 steps and then scream and think to itself, huh, where am I? There you go. Cool. So that is how we code our polar bear to move 70 steps, start sound scream, and think to itself, huh, where am I? Hi everyone! In today's tutorial, we're going to explore the motion blocks. When we open up Scratch 3.0, we have our motion blocks in blue. We're going to go through all the motion blocks and check out what each of them does. Let's look at the first few blocks that we have. With our first block, it says move 10 steps. So Kitty is actually in a grid coordinate on stage. So move 10 steps means move 10 steps to the right. Since it's a positive number, it's moving to the right. If we change it to -10, then Kitty moves backwards, -10 as in going to the left of the stage. If we change it to 50, it's going to make big steps. So 50 makes big steps, and if we go -50, it's going to make big steps to the left. Turn 15 degrees clockwise makes the kitty turn clockwise from its original position. And if we change it to maybe 30, then it makes bigger turns. If we do anti-clockwise 15 degrees, it goes the other direction. If we change it to 30, then it makes bigger turns. Previously, Kitty was facing this side of the stage, but now it's looking over there. So now when we click on move 10 steps, Kitty is going to move 10 steps to the direction that it is facing. So if we click on it, Kitty is moving towards this direction because that's the direction that it is facing. Now let's go ahead and look at go to random position. These two are basically the same code block, except that this one has glide 1 seconds too. So now I'll explain first what this one does. So go to random position places Kitty at a random position on the stage. We also have the option to change it to mouse pointer. So since I have my code block when spacebar is pressed, Kitty is going to go to my mouse pointer. So it goes to the mouse pointer location. Kitty is just going to move right away to where my mouse pointer is. Now with this one, instead of going right away to my mouse pointer, it's going to take 1 second for it to come to my mouse pointer. So if we hit the space bar, it takes a little bit longer for it to come to my mouse pointer. So let's change it to 3 seconds. Then it takes forever for it to reach my mouse pointer. But we can also change the speed to maybe like 0.1, and it's going to go really fast. Super quick. So that's what's different between these two blocks. They're basically the same thing, except that this one has glide blah 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 seconds to the mouse pointer, whereas this one just goes straight to my mouse pointer. Now let's go ahead and look at these guys. Instead of going to a random position or where my mouse pointer is, this one goes to a specific grid coordinate. So if I want Kitty to go to the center of our grid coordinate, I can set it to 0, 0, and Kitty gets placed there. So for this one, just like what we did before, if we wanted to take 3 seconds for it to get to coordinate 54,61, then when we click on it, it's going to take 3 seconds for it to reach 54,61. Like I said, since Kitty is in a grid coordinate, if I make her go 50 on the x-axis, it's going to go to the right 50. And if I make it go 50 on its y-axis, it's going to go up 50. If I go negative 50 on the x-axis, it's going to go to the left. Negative 50 for the y-axis, it's going to go down. The maximum number of value that Kitty can go in its x-axis is 240 positive and negative 240. For the y-axis, the maximum it can go is 180 positive and negative 180 down. Now we have point and direction. What point and direction does is make Kitty face a different direction, kind of like what we did with turn 15 degrees. But we're just setting it to, instead of animating it, we're just setting it to face a different direction. We can set the cat to face negative 90. We can also set it to 0. We can also set it to 180. But notice how when we set it to negative 90, the cat is flipped upside down. If you don't want the cat to flip upside down, we can come to this direction button over here in the sprite panel. And we have 3 tools that come up. We have the all around, left or right, and do not rotate. So if we click on this one, Kitty is now facing the other direction. So instead of going more than 180 degrees, when it reaches 181, instead of flipping upside down, it flips to the other direction. And when we click on do not rotate, it doesn't rotate at all. So what this does is set the appearance to not be rotated. This means it's only affecting the outer look of the cat, but not its point and direction. So when we make it go 50 to the right, make it go 50 steps, it's not going to go this way, but instead it's going to follow its point and direction, which is this way. So when we click on move 50 steps, notice how Kitty is not going this way, but instead that way, because it's going according to its point and direction. Instead of having Kitty have a set point and direction, we can also make it point towards mouse pointer. So when we hit the space bar, Kitty is going to face my mouse pointer. Now let's look at these guys. Change x by 10 means change x by 10 from its original position. So currently it's on negative 84. Let's make it 0 so that it's easier for us to understand. So from coordinate 0, we want it to go x by 10. So 0 plus 10 is 10. So every time we click on it, it's going to go plus 10. So if it's in maybe let's say like 54 and we click on change x by 10, it's going to go 64. We can also go negative by hitting negative 10. So it's going to go 84, hit one more time, and it's going to go 74, 74, 64, 54, 44. Instead of changing x by negative 10, we can also set Kitty to go to a specific value. We can make Kitty go set x to 0 and make her go to the center of the stage. The same thing applies for change y by 10 and set y to negative 8. So if we do change y by 10, so currently it's on negative 8, but it's going to go to 2, 12, 22. We can also set Kitty to go to a specific coordinate like 0. It's already on 0. We can make Kitty go to 100. We can also make it go negative 100. And it goes to the specific coordinate we ask it to go to. We have a few more blocks left. if on edge bounce. Now this one is a little bit fun to play with, so let's code it like this. So this is how we're going to code. When the spacebar key is pressed, it's going to go into a forever loop. It's going to move 10 steps, and if it reaches the edge of the stage, then it's going to bounce back. So let's hit the spacebar and see what happens. It starts moving 10, and it bounces back when it reaches the edge of the stage. Now let's look at set rotation style. Set rotation style is basically what we had under the direction panel. It's the three options that we have: the all around, the left and right, and don't rotate. We are currently on left and right, so that is what we have right here. So you can either change it over here or use a code block to set the rotation style. We also have these round rectangle blocks that we can use for specific ones like this. So we can plug it in, and when we hit the checkbox, it displays our current X position. So using this will allow us to see where our sprites are located in the grid coordinate of the stage. So that was all of our motion blocks that we have. We looked into each and every one of them and see how they run. For this challenge, I want you to script a scene where a doggy and a mouse are in the woods. The mouse is moving around and the doggy tries to catch the mouse. First, change the background to the woods. For the mouse, we want to first code so that the mouse starts moving when we hit the green flag. We want the mouse to be moving in a point in direction of 45 degrees, but still face to the right. You will have to change its rotation style to do this. Before we move, we want to check if the mouse is on the edge of the screen. So make sure to code that if the mouse is on edge, it bounces. And lastly, for the mouse, we want to place the two blocks of code in a forever loop, which is under the control blocks. For our dog, we want to get the dog to start running its code when we hit the space key. Code so that the dog points towards the mouse pointer. Make the dog glide 0.1 second to the mouse pointer. Lastly, we want to make the dog bark. So have a go and see if you can get it right. The answer key is going to be provided for you, so check it out after you finish the challenge task. We will first need to change the backdrop to the woods. So let's bring in our woods backdrop. Now let's get rid of our kitty and bring in our dog and mouse. Remember, we want the mouse to be moving in a point in direction of 45 degrees, but still face to the right. So let's code our mouse to move 10 steps, but in the direction of 45. But we want it to face to the right, so we'll change the rotation style to do not rotate. And now when we make it move 10 steps, it's moving in point and direction of 45 degrees, but still face right. We want the mouse to be moving constantly, so we'll put it in a forever loop, but we want it to move still within the stage. So let's bring in our if on edge bounce block, which is over here and under the motion blocks. So it's going to stay on stage. Good. And now we want it to start when we click on the green flag. So let's finish it off like that for our mouse. Now we are ready for our doggy. So for our doggy, we want it to follow the mouse pointer. So we're going to make it glide to our mouse pointer, and we'll make it faster. Let's make it 0.1. And we also want it to point to the mouse pointer. So point towards mouse pointer. And we also want the doggy to make a barking sound when we make doggy run its code. So that's the default sound it has. Yes, we want that. So under our sound blocks, let's bring in our play sound block. And we want the doggy to run its code when we hit the space key. So let's bring in this one. And now we are ready. Let's go ahead and see if it works. Oh, let's set the green flag so that the mouse runs. Yep. So that is it for this challenge. I hope that helped you review the blocks of code that we learned. Hi everyone! In today's tutorial, we're going to go ahead and look at our looks blocks. The first few blocks can be categorized into two, our say blocks and our think blocks. We have two different say blocks. The first one puts up the hello speech bubble forever on our stage, and the second one places our hello speech bubble for only 2 seconds, and then it disappears. So for 2 seconds and then disappears. This one just displays the speech bubble forever on our screen. The same goes for our think blocks. This one just leaves the thought bubble on the stage forever, whereas this one leaves it only for 2 seconds and then disappears. Next, we have our switch costume blocks. So what this one does is, remember, we have 2 different costumes for our kitty. So if we click on the next costume, it goes to the next costume and then goes in a loop. So if we have 3 different costumes, it's going to go 1, 2, 3, and then 1, 2, 3. So it's going to go to costume number 2, and then costume number 3, and then our very first costume again. With this block, we can switch costume to a specific costume. So we can switch it to costume A or Abby. We can also name our costumes. So for cat B, we can name it to Running Kitty. So when we come back to this code block, it says Running Kitty, and when we switch it from Abby, we can make it go to Running Kitty. Our switch backdrop basically does the same thing. So first, let's add another backdrop. Let's add an Arctic and a basketball court. So we have 3 backdrops. When we click on next backdrop, it goes back to the first one, then goes to the second one, and then goes to our third one. Same thing with our switch costume block. We have a number of blocks. We have different options we can choose from. We can choose switch backdrop to Arctic, or we can switch it to basketball. We can also set it to next backdrop or previous backdrop or random backdrop. We can change the size of our kitty by 10, so it's going to grow 10 units bigger, or we can set it to -10, which means it's going to get -10 units smaller. Set size to 100% means its default size is 100%, but we can make it smaller by going 30%, maybe a little bit bigger, 50%, or we can go 200% and make it really, really big. Change color effect by 25. Now this one gets a little bit fun. So if we go to our costumes panel, we have our kitty's fill panel. So we can move our slider from left to right, and the color starts from one end to the other, and its value goes from 0 up to 100. So when we say change color effect by 25, that means we're going from 0 all the way to 100. So when we say change color effect by 25, it changes to a different color. That means it's going up the slider. Now, we can also set its color effect to a certain color. 0 means it goes back to its default color, and from its default color, we are going to set its color effect to 52. But if we look at it, if we go to color 52, it's a little bit different than what we have. And that is because we are going to color 52 from this color, from cat's original color, not from color 0. So it makes it a little bit different. We can also change its fisheye effect. And we can also change its whirl. We can change it to be more pixelated. We can change it to be less pixelated. We can change the mosaic, brightness, and ghost. Now, ghost is quite fun to use, especially when we have another sprite. Let's bring in an apple. So when another sprite is overlapping, and we make it kind of transparent, then we can see Kitty through the apple. Now we can see the apple through the kitty. Yes. So that is how it can be used. And clear graphics gets rid of all the graphic effects that we have placed on Kitty. Show and hide is pretty self-explanatory. We are showing our kitty and we are hiding our kitty. Show, hide, show, hide. Go to front layer, go forward one layer. These are pretty helpful when we have more than one sprite. So let's bring in another sprite. I will bring in a banana, place it somewhere over here. Now go to front layer. Conventionally, whatever you press, whatever we click on the very last is going to be on the very top layer. But if we want Kitty to be on the very front layer, we can use this code block to make Kitty be on the very front layer. We can also make it go to the very back layer, or we can set it to go forward a specific number of layers, so maybe just one, or we can make it go 2 layers back or forward. We can also make it go backward 2 layers or forward 1 layer. We also have our round rectangular blocks, and these are helpful in presenting our values. So when we click on the checkbox, it helps us see the costume number that Kitty is on, the size that Kitty is on, which is 100%, and the backdrop number. We are on backdrop number 3. So that is it for our look blocks. We went through each and every one of them and saw how they change our kitty. For this challenge, I want you to script a scene where the hen shouts cock-a-doodle-doo when the green flag is hit. The hedgehog gets surprised and shouts "yah." When we click on the egg hatches and the chick comes out of its eggshell. So have a go and see if you can do the challenge task. The answer key will be provided, so make sure you check after you've finished it. Change the backdrop to a farm. Let's get rid of our kitty, and let's bring in our 3 sprites, our hedgehog, our hen, and our hatchling. Let's first code our hedgehog. So for our hedgehog, we wanted to change its color effect by, let's say, 120, so that we can clearly see that the hedgehog changed its color. And after that, we wanted to say "yah." So under the sounds panel, let's bring in the "yah" sound. Yeah. Okay, that sounds right. Let's bring in our sound block. Play sound "yah" until done. And that's going to be it for our hedgehog. So when the green flag is hit, it's going to run all this code. So let's have a go. Yeah. Yep, it changed its color and it said "yah." Now let's move on to our hen. We want the hen to say cock-a-doodle-doo. And we want it to switch its costume to hen D so that it's facing down like that. Let's put our hatchling over there. So from A, it goes to costume letter D. So let's bring in switch costume to hen D. And that is it for our hen. Now for our hatchling. When we click on the hatchling, we want it to switch to its next costume. So it goes from hatchling A to B, then to C. So under the look category, we will bring in the next costume block. We also want to make sure that it is on the very front layer so that it's not hiding behind the hen. So let's have a go. When we click on the green flag, the hedgehog is going to change its color and say "ya." The hen is going to say "cock-a-doodle-doo" and face down. When we click on the hatchling, it's going to hatch, and that is going to be the end of our code. So let's have a go. Yeah. Cock-a-doodle-doo. When we click on the chick, it hatches. Cool. So that is it for this challenge. I hope that helped you understand better what the look blocks can do. Hi everyone! In today's tutorial, we're going to go ahead and look at our sound blocks. In Scratch 3.0, every sprite comes with their own default sound. So for a kitty, this is the sound that it comes with. If we bring an apple, it also has a default sound that it comes with. Now let's go ahead and look at our first three sound blocks. Play sound meow and start sound meow sounds like the exact same blocks, but they're a little bit different. To show you the difference, let me bring in another sound from the sound library. So I'll click on this button, choose a sound, and I'll look for classical piano. So that is what it sounds like. Now, I will code it a certain way so that I can show you the difference between the two. So, what this does is, with this one, it plays the classical piano until the song is done playing, whereas this one only plays the sound for 1 second and then puts itself in a loop. So let's start with this one. And then it plays again once it's done. After it's done playing, it waits for 1 second and puts itself in a loop again. Let's try this one. As you can tell, it plays only 1 second of classical piano and puts itself in a loop over and over again. So it's only playing the first 1 second of the song and playing it again and again and again. Now let's look at our change pitch blocks. How our change pitch works is when we change the pitch effect by 10, by positive 10, it means it's going to get faster and higher. So let's maybe make it 50. So if we hear the original sound, that is the original, but if we change the pitch effect by 50, it gets faster and it got higher. We can also set the pitch effect to a certain number. 100 is its default, but if we change it to -20, it gets slower and the pitch got lower. The same thing happens with this one. If we change effect by -20, the more we press it, the slower it gets and the pitch gets lower. Clear sound effects and it goes back to normal. Change volume by -10, set volume to 100%. So change volume by -10 is changing the volume, and now it's mute, and we can also change it to 10. Make it louder, press it again, and it got louder and louder. We can also set it to a specific volume. 100% is the max volume, so if we go from, so let's play 100%, And because 100% is the maximum, if we go to 100%, it's going to sound exactly the same. We can also reduce down the volume to 20%. We can bring it back up to 100%. And that's all the sound blocks that we have. For this challenge, we are going to have a rapper rap on stage. So first, change the background to spotlight. When we hit the green flag, we want to hear cheering sounds. For the rapper, we're going to use the champion sprite. We want him to start a beatbox whilst changing his costume when the sprite is clicked. To do this, put him in a loop. Have a go and see if you can make it. The answer key will be provided, so make sure you check after you're done. Change our backdrop to spotlight. Let's get rid of our kitty and bring in a champion. And he's going to be our rapper. Let's change his size to 60% so that it matches the background. Now before the rapper starts rapping, we want to hear some cheer sounds. So let's bring in some cheer sounds. That sounds good. Let's bring in that. So when we hit the green flag, we immediately want to hear that sound. So play sound cheer until done. Now, once the cheer sound is done, we want our rapper to start rapping, but we want him to start rapping when the sprite is clicked. So let's bring in this block, and we want him to start beatboxing. So let's bring in the beatboxing sound. That sounds good. So let's bring in the play sound beatbox 2 until done. And we want him to repeat that sound so that it sounds as if he's actually beatboxing. That doesn't really sound like real beatboxing, but that's okay. For this challenge, we'll just go with that. Now we also want him to change his costume so that it looks like he's dancing and grooving along with his own rapping. So let's leave A and F and delete the rest so that it looks like he's grooving and doing the rapping gesture, whatever that is. So now let's bring in our next costume block. Now we are ready, so let's go ahead and be on full screen. When we hit the green flag, we're going to hear the cheer sound, and when we click on our rapper, he's going to start rapping as he changes his costume. When we click on him, he starts dancing and he starts rapping as well. So that is it for this challenge. I hope that helped you understand how we could play around with our play blocks. Hi everyone! In today's tutorial, we're going to go ahead and look at the event blocks. The event blocks are the ones that we see over here in yellow. There are only a few, but they are very important. Event blocks are the ones that have a cap on them, because they are the starting blocks. This means they can have code underneath them, but not above. So let's go ahead and look at the first few of the event blocks that we have. When green flag is clicked is the one that we use a lot of times. So let's say I bring in say hello, and when I click on the green flag, Kitty is going to say hello. Hitting the green flag is what triggers this block, and when this statement is true, it moves on to the next line of code. So let's move this block to the next one. When space key is pressed. So what triggers this block of code is when the space bar is pressed, then the statement is true, then it goes on to the next line of code, which is making Kitty say hello. So when we click on the green flag, nothing happens because what triggers this block is the space bar. So when I hit the space bar, Kitty says hello. If I move on to this one, nothing is going to happen when I click on the green flag. Only when I click on Kitty is it going to say hello. Hello, there you go. Let's look further at what this one can do. We can use this code block to switch between two different backdrops. So let me bring in another backdrop. I will choose Castle 3. And when up arrow key is pressed, I want it to switch to backdrop 1. And when the down arrow key is pressed, I want it to go to the castle. So when I click on the green flag and hit the up arrow key, it moves to backdrop 1. And when I hit the down key, when I hit the down key, Kitty goes to Castle 3. Now let's look at this one. When backdrop switches to backdrop 1. When backdrop switches to Castle 3, I want Kitty to change its size so that it's more proportionate to the staircase. So I want Kitty to change its size to 70%. So what this does is, when this statement is true and the backdrop is switched to Castle 3, only then would this block of code be triggered and go to this line of code. So these two are now working together. Only when this happens will this line of code start. So let's hit the green flag and go back to backdrop 1 by hitting the up arrow key, and then go to backdrop 2, which is the Castle 3, by hitting the down arrow key, and Kitty now reduced its size to 70%. Now let's look at this line of code, when loudness is greater than 10. Instead of using loudness, we more often than not use it for the timer. So let's bring in the timer from the sensing blocks and click on its checkbox. Now as you can see, we see the timer on stage. The timer starts counting the moment we hit the green flag. So when we hit the green flag, it starts from 0 and then goes all the way up until we hit the green flag again. If we want to reset it, we can also bring in the reset timer block and click on it, then it resets its timer. With this block of code, we can do very specific things, such as after 3 seconds, I want Kitty to say hello. So we can bring in this block and change it to 3. So when we reset the timer and it starts and it hits 3, then Kitty is going to say hello. So let's reset the timer, goes back to 0, and once it is 3, then Kitty is going to say hello. We can do other different things, such as we want Kitty to hide after 3 seconds, then we can do that. So let's reset the timer, goes all the way back to 0 and then goes to 3, and Kitty is now gone. We can do the other way around, where we want Kitty to show after 3 seconds. So when it hits 3, Kitty shows up. So with this block of code, you can do many different things. Now let's look at the 3 remaining blocks of code. These 3 are really helpful when we are using more than one sprite. So let me bring in an apple to demonstrate. I'll put it next to the kitty. Now let's say I want the apple to change its color when I click on Kitty. So when the sprite is clicked, I want Kitty to change apple's color. So if we do this, instead of apple changing its color, Kitty changes its color, but we want it to be the other way around, where when we click on Kitty, apple changes its color. So that's when these guys come in. These blocks of code are going to be like a bridge between sprite 1 and sprite 2. So when this sprite is clicked, we want it to send a message to Apple saying, change your color. So let's create a new message and name it change Apple's color. So when Apple receives that message, it changes its color. So now when we hit the green flag and we click on Kitty, Apple changes its color. So it becomes a bridge between sprite 1 and sprite 2. So when one thing happens, it triggers this block of code and it moves on to the next line of code. So when this statement is true, it triggers this block of code. Now let's have a look at the difference between these two code blocks. They look the same, but they're slightly different. This one says broadcast change Apple's color, and this one says broadcast change Apple's color and wait. To show you the difference, let's make Apple wait 1 second before it changes its color. And I will code kitty like this. So these two are basically the same thing, except that this middle code is different. This one says broadcast change apple's color, but this one says broadcast change apple's color and wait. So let me try this one first. When I click on this one, kitty says meow, and then apple changes its color. Let's have a look at that again. Oh, whoops. Let me change it to red again. So after it says meow, apple changes its color. But if we click on this one, kitty says meow as apple is changing its color. So it happens together at the same time. Let's have a look at it again. So what is the difference between the two? So when we click on this one, the meow sound starts right after the message is broadcasted. So what is happening is that for this block of code, all its task is to send a message to Apple. So as soon as that's over, it moves on to the next line of code. So even before Apple changes its color, this line of code is already running. So the moment it's broadcasted, then it goes to say meow. But for this one, it says broadcast, change Apple's color, and wait. What wait means in here is wait until Apple finishes all its line of code. So broadcast, change Apple's color, and wait until Apple changes its color, then say meow. And because Apple is waiting for 1 second, it sounds as if they're happening at the same time. But in reality, it's actually waiting until Apple finishes all its lines of code and then says meow. So it's slightly different, but it's useful when we are coding very specific things where time actually matters. So those are all the event blocks that we have. Event blocks are used a lot when writing our code, so it's good to try out the different blocks to understand how they work. For this challenge, we will make Devin visit Dee's house and go on a house tour. Script so that Devin asks Dee to show around his rooms and for Dee to give Devin a room tour. They will start from the backdrop called Room 2. For Dee, when the sprite is clicked, Dee says, "Hey, what up, Devin?" for 2 seconds. And then he replies, "Haha, sure," for 2 seconds. For Devin, when he receives a message from Dee to start speaking, he replies, "I am doing good," for 2 seconds. Then he asks, "Can I see some of your other rooms?" Devin will also have another block of code. When the backdrop switches, he waits 2 seconds first, and then he says, "Wow, your place is amazing!" So have a go and see if you can create the scenario. The answer key will be provided, so make sure you check when you're done. Change the backdrop to room number 2. So let's bring in room 2, get rid of our kitty. We're going to bring in Dee and Devin. So Dee is the owner of the house, and when we click on Dee, we want him to say, "Hey, what's up, Devin?" For 2 seconds, he says, "Hey, what up, Devin?" And then he broadcasts a message to Devin. And we want him to wait. So it's going to be a new message, and let's name it Start Speaking. So it's like sending a signal to Devin saying, "Hey, once I broadcast you this message, do something." So what wait means is, remember, we want Devin to run all its code, and then Dee is going to run the rest of his code. So Devin, when he receives that message, he starts speaking. He says, "Doing good, Dee," for 2 seconds, and then he says, "Can I see some of your other rooms?" And when Devin is done with his code, D says, haha, sure. Then after he says that, he switches the backdrop to a different room. Let's bring in room 1. And he's going to switch the backdrop to room 1. So D first starts off by saying, hey, what up, Devin? And then he sends a signal to Devin saying, start speaking. When Devin receives this message, he says, doing good, D, and asks, can I see some of your other rooms? Then after Devin is done running all his lines of code, D says, haha, sure. And then he switches the backdrop to room number 1. When the backdrop switches to room number 1, we want Devin to say, wow, your place is amazing. So let's make him wait for 1 second and then say, wow, your place is amazing. So let's hit the green flag and see how the code runs. When we click on D, he says, hey, what up, Devin? D says, doing good, D. Can I see some of your other rooms? Aha, sure. He switches the backdrop, and then Devin says, wow, your place is amazing. So that is it for our challenge task. I hope that helped you understand how we can use the different event blocks that we have. Hi everyone! In today's tutorial, we're going to learn the control blocks. The control blocks are the one in orange. The very first block that we have is wait 1 second. This is pretty self-explanatory, so we're making something wait for 1 second before it goes on to the next line of code. We can also change it to decimal points like 0.1, then it's probably going to wait for a really short time and then move on to the next line of code. Repeat 10 times and repeat forever. If we put in a block of code such as this change color effect by 25, if we put it on this one, Kitty changes its color 10 times. But if we put it on this one, Kitty changes its color forever. Now we have the if-then blocks. So previously we had round rectangle blocks, but here we see hexagon blocks. So the round rectangle blocks that we had before, like the timer, what was inside of them was numerical values. We see numbers stored inside of them. But for hexagons, they are true or false statements. So, is the mouse pointer touching Kitty? False. No, it's not. So these are called binary statements. It can only be true or false. So let's say we want something to happen when the mouse pointer is touching Kitty. So if the mouse pointer is touching Kitty, let's say we want Kitty to make the meow sound. But if we hit the green flag and try to check and see if it works, it's not working because as soon as we hit the green flag, it runs its code and it's done. So by the time my mouse is reaching over to Kitty, the code is already run, so we are running out of time. So instead, we will put it in a forever loop so that it's constantly checking to see if the mouse pointer is touching Kitty. So if we hit the green flag, it makes a meow sound whenever the mouse is touching Kitty. We can also use this if then else statement. So if the mouse pointer is touching Kitty, then we want it to be a bigger size. We can set it to, let's say, 150. So with this one, when the mouse pointer is touching Kitty, then it makes a meow sound. But when the mouse pointer is not touching Kitty, then it does nothing. But with this one, we have another block of code that we can plug in. Let's say when it's not touching Kitty, we want the size to be like 40 and be really, really small. So if we hit the green flag, we need the forever loop. Remember, we need the forever loop so that it's constantly checking if the mouse pointer is touching Kitty. So when we hit the green flag, When the mouse pointer is not touching Kitty, then the size is set to 40%. If the pointer is touching Kitty, then it goes to 150. So is the mouse touching Kitty? Yes, it is true. Then set size to 150. If the mouse is not touching Kitty, then the statement would be false. If it's false, then set size to 40%. Now let's look at the wait until block. This looks similar to our wait for 1 second block, but they're a little bit different. So for this one, what matters is the number of seconds that we want it to wait, whereas this one is conditional. Wait until something is true. So we can make it wait until the mouse pointer is touching Kitty. I will show you the difference by using these two blocks of code. So for our first one, when the green flag is hit, we want to make sure all graphic effects are cleared out. So clear graphic effects, wait for 1 second, and then change its color by 25. So we'll do the same for this one. When the green flag is hit, we make sure we clear all graphics, and then wait until the mouse is touching Kitty, and then change its color effect by 25. Let's bring in the size back to 100%. Okay, so when we click on this one, after 1 second, Kitty changes its color. Let's look at that again. 1 second and then changes its color. But if we click on this one, Kitty doesn't change its color until our mouse pointer comes to Kitty. So that is the difference between the two blocks of code. This one sets the specific number of seconds, whereas this one waits until a certain condition is met. Repeat until and repeat 10 are basically the same thing as the difference between wait 1 seconds and wait until. So same with these guys. So this one repeats 10 times and this one repeats until a condition is met. So this one repeats 10 times and then stops its code. This one keeps on repeating its code until a certain condition is met. Then it stops its code. So I'll show you the difference. Now let's have a look at our code. When we click on the green flag, whatever the code blocks are inside of this repeat block is going to be repeated 10 times and then be stopped. Whereas this one, when the green flag is hit, it repeats these two blocks of code again and again until the mouse pointer is touching Kitty. So let's try this one first. It changes its color 10 times and then stops. Whereas this one, it keeps on changing its color forever until my mouse pointer is hovering over Kitty. Then it stops its code. Now let's look at the stop block. In this stop block, we have stop all, stop this script, and stop other scripts in Sprite. To show you how it works, I will prepare myself some code blocks. Now let's have a look at our code. When the green flag is hit, it's going to start from size 10% and then it keeps on adding size +1. Whereas this one keeps on changing its color. So when we hit the green flag and we play both of our codes, it's going to grow big because it's changing its size by +1 and it's also changing its color. Now I'm going to make a duplicate of this sprite, and now I have two sprites. When I click on the green flag, both of them are running. But if I click stop all, it stops everything. It's basically like the red button. Now I'm going to use stop this script. So to do that, I will tweak a little bit of my code. So what we have done is, if we click on the space key, we're going to stop this script, which means all the blocks in this one. But this one is still going to go on. So it's going to change its color effect by 25, but only these guys are going to stop its script. So let's hit the green flag to see what happens. It grows and changes its color, but when we hit the spacebar, it stops all these scripts over here, but it continues this line of code. Now let's change it to stop this script. Now let's change it from stop this script to stop other scripts in Sprite. What this does is do the other way around, where this one gets stopped and this one continues its code. So it stops other scripts in Sprite, as in this other script, whereas this one is going to continue running. So when we click on the green flag and we hit the space key, it's going to keep on growing but stop changing its color effect. Our last 3 blocks. When I start as a clone, create a clone of myself, and delete this clone. So, what exactly is a clone? To show you this, I will bring in this trigger block. When space key is pressed, create a clone of myself. And I'm going to make it move 10 steps. So the original sprite is going to move 100 steps after it creates a clone, because if we don't move 100 steps, then the clone is going to be pasted right in front of myself. So we won't be able to tell if a clone is made. So after it creates a clone, the original is going to move 100 steps. So our clone is going to be here, and our original sprite is going to move 100 steps to the right. So when we click on the spacebar, hit the green flag and click on the spacebar, we created another clone of ourselves. Now later on we will look at the stamp block, but a stamped sprite will be stuck on the stage and we won't be able to move it around with our mouse. But as you can see, a stamped clone can be moved around with our mouse, and it can even be coded. So when I start as a clone, we can make it change its color. In a forever loop, we can make it change its color. So if we hit the green flag again and press the space bar, our clone keeps on changing its color. We can also delete our clone using this delete this clone block. So when our mouse pointer is touching on our cloned kitty, it's going to disappear. So when we hit the space bar, a cloned kitty is going to appear, and our original kitty is going to move 100 steps to the right, and the clone kitty is going to keep on changing its color until we hover over it. Then it's going to disappear and get deleted. Okay, now let's hit the green flag and hit the space key. Our clone is created, and now it's going over the loop over and over again, changing its color, and when we hover over it, it's going to disappear because it's deleted. Boom, got deleted. So that is all of our control blocks. If you master these control blocks and know how to use them well in different ways, it will be really helpful when creating games with it. So explore how you can use the control blocks in different ways, and you will find more creative ways to come up with games. For this challenge, make Kitty leave a clone wherever she goes, and the clones are all going to start walking as they change color. Leave a gap of 0.5 seconds in between the clones' costume change. For Kitty, when space key is pressed, make it go in a loop of creating a clone of itself. After creating the clone, make it glide to a random position on stage. And if on edge, make it bounce. For the clones, when they are created, make them change to the next costume, also change color, and make them glide 1 second to the mouse pointer. Make it wait before it goes into another loop of changing its costume. Create another block of code where, when the timer exceeds 10 seconds, stop all the scripts on stage. The answer key will be provided, so make sure you check when you're done. When space key is pressed, Kitty creates a clone of itself. Now remember, when we create a clone, the clone is going to be behind our original sprite. So we want our kitty to move to a different place. Let's bring in glide 1 second to random position. But let's make it move a little bit faster, so let's change it to 0.5. And again, if on edge bounce, so that kitty stays on stage. Let's put that in a forever loop. So as long as the key space is pressed, it's going to start creating heaps of clones by itself. For our clones, we want them to look like as if they're walking. So it's going to switch from costume 1 to costume 2. So let's bring in our next costume block. We also wanted to change its color. So bring in the changed color effect by 25 block. Let's make them move as well. So under our motion blocks, let's bring in glide 1 second to mouse pointer. Let's make it mouse pointer so that all the clones all clutter into one area wherever the mouse is going. Let's make it wait 0.5 seconds before we put it in a loop. So let's put all these guys in a forever loop. So when they start as a clone, they're going to start switching their costume, change its color effect, so it's going to go really crazy and change its color. And we want it to all clutter into one area where the mouse pointer is, and it's going to wait 0.5 seconds before it goes in another loop. So it's going to go pretty crazy. So let's hit the space key and see what happens. Kitty starts moving, and all the clones are cluttering to where my mouse pointer is. Now, once we make heaps of clones, it's going to go really crazy. So let's set a timer where when the timer is greater than 15, so when it's past 15 seconds, we are going to stop all our code. Stop all. Remember, stop all means stop everything over here. So let's hit the green flag and see how our kitty creates its clone. And then once the timer hits 15, all the clones are going to stop. There you go. So that is the end of this challenge task. I hope that helped you understand how we could use our control blocks for different things. Hi everyone! In today's tutorial, we're going to learn the sensing blocks. The sensing blocks are the one in blue. The very first one is touching mouse pointer. So this is the one that we used before. It's the binary statement one with true or false. So let's bring in our forever loop and make Kitty say the statement true or false. So if we hit the green flag, Kitty says false because my mouse pointer is not touching Kitty, but when I am touching Kitty, it says true. Touching color. This checks to see if the sprite is touching a certain color. So this is useful when we have another sprite. So let's bring in an apple. So we can check and see if Kitty is touching apple. Apple's red color. So we can use this eyedropper tool and pick up Apple's red color. So if Kitty is not touching apple, then it says false. But if it's touching the red color, it says true. If it's not touching any red, then it says false. But if it touches the red part of apple, it says true. We can also be very specific with our colors using this color is touching color block. So we can say, is Kitty's white part touching the apple's brown part? So when we hit the green flag, false. No, the white part is not touching the brown part of apple. So when it's touching the red part, it still says false. But when the brown part of the apple touches Kitty's white part, it says true. So if it only touches the red part, it says false. No, the white part is not touching the brown part. But if it touches the brown part, it says true. Yes, Kitty's white part is touching the brown part. Distance to mouse pointer. This is calculating the distance from Kitty's center point. Kitty's center point is somewhere over here, but the further away I go from Kitty's center point, the number increases. And if I come closer to Kitty, the number decreases back. Ask what's your name and wait. This one brings up a text input. So this thing comes up, and if I type in my name is Valencia, then it stores my answer. So if we bring in this answer block and click on the checkbox, then my answer is stored over there and I can see it on stage. Key space pressed. This one checks to see if the key space is pressed. So if I don't click on my spacebar, then it says false. No, the spacebar is not pressed. But if I press on it, then it says true. Yes, the spacebar is pressed. Mouse down. Mouse down checks to see if my mouse is down. So when I click on the green flag, it says, no, my mouse is not pressed down. But if I click on it, my mouse is pressed, then it says true. Mouse X and mouse Y. These tell me the X and Y values of my current mouse position. Because my mouse is in a grid coordinate, when I click on the green flag, it tells me where my mouse is on its X-axis. When I put in Y, it tells me my Y-axis. Set drag mode to draggable. So by default, when we have our stage on full screen, we actually can't drag our sprites. But if we set our drag mode to draggable, then our sprites become draggable. But notice how the apple is draggable, but our kitty is not. That is because we only set our apple to be draggable and not our kitty. It only applies on the sprite where we set our code on. Loudness refers to the loudness of our mic. So our input right now, if I whisper and make it really, really quiet, then it goes down to a very small number. But if I say really, really loudly, then the number goes high up. Timer is what we looked at before. It starts counting the moment I hit the green flag. So it starts from 0 and then starts counting up. Backdrop number of stage. Currently, I am in backdrop number 1, so it tells me that I am in backdrop number 1. If I change it to apple, it tells me the X position of apple. It also tells me the Y position of apple, the direction, costume number, costume name, size, and volume. The reason why we want this is if we were to know our own position of our own sprite, as in find out the X position of Kitty, then we can use our X position on the motion block. We can find out the Y position from our motion block and also the direction. But if we are trying to find out Apple's position inside Kitty, then we can use this block under our sensing blocks. Current year. Current year tells us the year that we are in, 2021, tells us the month, date, day of week, hour, minute, and second as well. You can also display it using the checkbox. Days since 2000 tells us the number of days since 2000. It's quite an interesting block to have. Username displays our username. I did not log in using a username, so it doesn't display anything. But if you were using it online and you have a username to log into your account, then it would display your username on stage. So that is all the sensing blocks that we have. Sensing blocks get used most often together with the event blocks right over here. So it would be helpful for you to know how to use the two types of blocks together, and it'd be easier when we are creating games. Ben has some food to try out in front of him. When he eats it, he says, "Wow, this food tastes so good." After he tries all the food, he gets a question asking which one he liked the most. When the green flag is clicked, we need to check constantly if the color of the food is touching Ben. We will need a forever loop and a color is touching color block. Secondly, when the color of the food is touching Ben's color, then he says, Wow, this name a food tastes so great. We will need an if statement block for this. As a separate block of code, after 15 seconds we want the pop-up question, what was your favorite food, to come up. The answer key will be provided, so make sure you check when you're done. Get rid of our kitty and bring in the character Ben. Let's place him here. Let's bring in our food. Let's bring in a fruit salad. Let's bring in a cake. And let's bring in a donut. Okay, let's click on Ben so that we are sure that we are coding on Ben. When we hit the green flag, we want Ben to constantly check if the color red is touching any of these food colors. So constantly checking, so we need to bring in our forever loop, and let's bring in our if block. So if the color red is touching the color blue of the fruit salad, then we want him to say, wow, this fruit salad tastes so good. And let's put that in our forever loop. Now let's duplicate this so that we create blocks of code that are checking to see if it's touching the birthday cake or the donut. So is the red color touching the birthday cake's pink cream? Then if it's yes, then he says, wow, this cake is so good. Let's duplicate it for our donut. Let's eyedrop this purple icing. So if it's touching the donut's purple icing, then it says, wow, this donut is so good. Now let's hit the green flag and see how it all runs. So if we drag our fruit salad, he says, wow, this fruit salad is so good. If we bring in the birthday cake, he says, wow, this cake is so good. For our donut, wow, this donut is so good. Now, after 15 seconds, let's say Ben asks us, what was your favorite? So let's go over here and bring in this block where it asks, what was your favorite? And he waits. So this happens after 15 seconds. There you go. We are done with our code, but there's one last thing we need to do. When we put it on full screen, remember by default our sprites cannot be dragged. So we need to code so that our sprites are draggable. So when the green flag is hit, we want our sprites to be draggable. So we're going to bring in set drag mode draggable. To duplicate these blocks of code, let's drag and release it onto our other sprites like that. So when we go to them, they have those blocks of code. Now if we go full screen and hit the green flag, they're draggable. So if we drag our fruit salad, he says fruit salad is so good, the birthday cake is so good, and the donut is so good. And once it's past 15 seconds, Ben is going to ask, what was your favorite? And we can type in whatever we want. I can say donut. So that is it for our challenge task. I hope that helped you understand more of what we can do with our sensing blocks. Hi everyone! In today's tutorial, we're going to learn the operator blocks. So for our first 4 blocks, we have the addition block, the subtraction block, the multiplication block, and the division block. Since there are only 2 inserts, you have to add a block inside a block if you want to calculate more than 2 numbers. So you can do this, but if you need 4 plus 1 to be calculated first, then the order of operation matters. You can also plug in pick random number from 1 to 10. So this will give you a random number. This time it gives a 6, next time it gives an 8, 1, and so on. This gets most often used when we are creating a game, so it's good to know that we have this block. Now let's look at these blocks. These blocks also give us true or false statements. So let's check and see. Is 30 greater than 50? No, so it says false. Is 60 greater than 50? Yes, that is true. Is 20 smaller than 50? Yes, that is true. Is 60 smaller than 50? False. Is 50 equal to 50? Yes, that is true. These would go inside blocks that have empty hexagons like the ones we saw in the control blocks. Now let's look at these 3 blocks, and or not. For this one, both hexagons have to be true in order for this entire block to be true. So is 50 50? Yes, it is true. But is 60 smaller than 50? No. So the final statement would be false. But if we make this true, is 20 smaller than 50? True. And is 50 50? Yes. Then the final statement would be true. For or, only one of the hexagon has to be true for the entire block to be true. So if 50 is 50 and 20 is smaller than 50, both of them are true. So yes, that is still true. But even if one of them is false, the final result is going to be true. For our not block, if the statement inside is true, then it would say it's false. And if the inside statement is false, then it would say that it's true. So 50 equals 50. Yes, that is true. But if we put it in our not block, it says it's false. But if we say 20 equals 50, which is false, then it's going to be true. These 3 blocks work well with the control block, so it's important to have a good understanding of them. This one literally combines the 2 words, apple, banana. So if we bring in another backdrop, and we bring in this one, and change it to backdrop name, the answer it gives is Arctic. So if we plug in that and say, also join it with background, the final answer would be Arctic background because we added the name Arctic and background together. Letter 1 of apple. That literally gives me the very first letter of the word apple. Length of apple gives me the number of letters there are in the word apple. Apple contains A. Does apple contain the letter A? Yes. It can also be more than one letter. Apple contains AP? Yes. It can also be phrases. So if we type in who are you, and if we ask are the words are you in who are you? Yes, they are. Now let's look at these 3. Modulo, round, and absolute of. Mod is short for modulo, and modulo is the remaining number after we divide 2 numbers together. So 5 divided by 2, the remaining number is 1. We use this a lot when we are looking for an algorithm, such as when we are looking for odd numbers. Round rounds up decimal points to the nearest whole number. And with this guy, we have so many options to choose from. We got floor, ceiling, square root, sine, cosine, and we have these complicated ones, but we won't go through the other ones in the bottom, but it's good to know that they exist in the program. So that is it for our operator blocks. Since operator blocks are very mathy, a lot of students might not like this section of Scratch, but the math that we use to program games with Scratch are easy math, so don't worry. We will be able to make fun games with just simple math. For this challenge, I want you to script this scenario. Chick asks Gobo what its favorite color is. Chick asks, "What's your favorite color?" And the pop-up question shows up. When we type in our answer will be what Gobo replies. Gobo will say, "Blank is my favorite color." The answer key will be provided, so make sure you check when you're done. For this challenge task, let's get rid of Kitty and bring in our sprites. Let's bring in Chick and let's bring in Gobo. Let's rotate Gobo -90 so that it looks like they're having a conversation. Okay, let's click on Chick so that we know we are programming on Chick. When green flag is hit, we want Chick to ask Gobo, what is your favorite color? So we're going to have a question that pops up, what is your favorite color, and be able to input our answer. The answer that we input is going to be stored in this answer block. So after that, Chick is going to broadcast a message to Gobo. We're going to name it favorite color. What this line of code is basically doing is telling Gobo to start speaking. So when Gobo receives the message, it's going to say, my favorite color is blank. So to do that, we're going to bring in our say block. And instead of typing in our answer, we're going to use the operator block, join operator block. So as you can see, there is actually a little space after apple, and that is because when we join apple and banana, the operator block is not going to add the space for you. You have to manually add that space by yourself. So what we're going to do is my favorite color is, and add a space. And like I said, the answer is going to be stored in this answer block. So whatever color that we say is our favorite color is going to be stored in this block. So we can just plug it in. And now our answer is going to be my favorite color is blank. If I say blue, it's going to be my favorite color is blue. So let's plug it in. And that is it for our code. So let's hit the green flag and see how our code runs. What is your favorite color? Chick is going to wait and not move on to its next line of code until we input an answer. I will say blue. Hit enter. And Gobo says, my favorite color is blue. And Gobo says blue because that is the answer that we gave. So that is it for this challenge task. It was a simple one where you get to learn how to use this join operator block. Hi everyone! In this tutorial, we're going to learn the variable blocks. By default, we have this block called myVariable. We can change its name to AA. We can also delete it by clicking delete. We can also add another variable by making a variable. Let's add a variable called BB. And we can click on the checkboxes to make them display on stage. With this block, we can set our variables to be a specific number. Let's set AA to be 5. As you can see, it is updated. And also set BB to be 5. BB has updated to 5. We can also use our show variable and hide variable to show and hide our variables from stage. So if we hide it, it gets hidden. And if we show it again, then it shows up again. Now let's try and make a list. Let's name it AAA. And our list comes up on stage. Let's try adding our very first item onto our list. So with this block, let's add in some fruits. I'll add a strawberry. And now, as you can see, we have added an item to our list. Let's add in a kiwi and a pear. You can also click on this plus icon over here on stage to add another item. I will add a durian. And now it has added its item to the list. Delete one of AAA. This deletes the first item in the list. So if we click on it, strawberry is going to get deleted. As you can see, strawberry is now gone. Delete all of AAA. This deletes all the items in our list. Insert thing at one of AA. This one inserts an item at a specific order in the list. So let's first add in some fruits. Let's add in back our strawberry, add in a pear, add in a kiwi, and let's say I want my durian to be the second item of our list. Then we can change it to 2, and if we click on it, durian is now the second item of the list. Replace item 1 of AAA with thing. What this one does is replace the item with what you insert, and you can choose which item you want to replace. So if I say I specifically want strawberry, which is item number 4, to be replaced with, let's say, an apple, then it switches to apple. Item 1 of AAA states the name or variable that is in the first item of the list. So currently we have kiwi as the first item, so it tells me kiwi. Item number of thing in AAA. This is the opposite of our previous block. This tells where the item is in the list. So if I say, where is kiwi in AAA? It's the very first item, so it tells me 1. Length of AAA tells me how many items are in the list. Currently we have 4, so if I click on it, it tells me 4. AAA contains thing. So if you ask, is durian in the list? The answer is going to be true. Yes, durian is in the list AAA. Is strawberry in the list? Remember, strawberry is no longer in our list, so the answer is going to be false. Show list AAA and hide list AAA. We can hide our list from our stage and we can make it appear again. So that is all of our variable blocks. It can get a little bit confusing, so it's good to review and be sure of what each of the block does. For this challenge, I want you to create a list called to-do list. Add in 4 tasks that you do in the morning, and then delete the 4th task. Replace item number 3 of to-do list with exercise. The answer key will be provided, so make sure you check when you're done. For this challenge task, I will first create a list. I'll name it to-do list. Now my to-do list pops up here. I'm going to make it bigger by using this bottom corner like that and just drag it. Now I want to add 4 tasks that I do in the morning. So with this add thing to-do list block, I'm going to say take a shower, brush my teeth, make my bed, and eat breakfast. Okay, now I have 4 items in the list. Now I want to delete item number 4 from my list. So I will bring in this block, delete 4 of to-do list. So that's going to delete my 4th item, which is eat breakfast. Now it's gone. Now I'm going to replace item 3 of to-do list with exercise. So I'm going to bring in this block, change item number 3 with exercise. So when I click on it, now it's exercise instead of eat breakfast. So that is it for this challenge. It was just getting to know how you could create your own list, add items, delete items, and replace items.